Hello, we are so excited to present Lafayette, brought to you by the Design Build Fly team at Lafayette College. My name is Zoe Ruslow, and I am technical manager of the team.
And I'm Lindsay Fagerstrom, and I'm the project manager.
I'm Tanner McFarland, and I'm the mission sub-team leader.
Despite challenging times and many hurdles that were faced due to the pandemic, we are proud to announce the successes of our team and are excited to present them to you.
Okay, so these show the three views of the final design of our plane, and we believe that our design is best to meet the mission requirements because the shape of the fuselage is designed to hold the containers as well as allows for easy installation for the deployment system. And the 60-inch wingspan was chosen in order to generate enough lift to hold our payload.
These are the dimension drawing files. The aircraft is 39.01 inches long and 17.59 inches high, with a wingspan of 60 inches. All of the demonstrated dimensions are consistent with the presented photos of our aircraft and the competition regulations. So there are many different parameters and specifications for the aircraft, and some of the most important ones are shown in this table here. So the wings weight itself is 5.98 pounds, and the tail is 3.3 pounds. The fuselage is 2.14 pounds. Each propeller is 0.08 pounds, and the motors are 0.7 pounds each. Then for the missions, we have the sensor weight of 0.08 pounds, and the containers are 0.45 pounds. That's with the sensor inside of them, or the simulator weight. The deployment mechanism is 0.23 pounds. And then the two batteries that we use for our propellers, we have a large battery that is 1.02 pounds and a smaller battery that's just under a quarter pound.
So a static thrust test was conducted, which consisted of the propeller and motor, which were mounted to a metal bar and configured to a load cell with the propeller connected to the circuit board receiver, electronic speed controllers, a fuse, a remote control to vary the throttle percentage, an ammeter for current measurement, and a laptop with code to read output values of throttle percentage and thrust in LBF. From this thrust test, it was found that the max status thrust per outrunner motor was 11.02 pounds, which meant for both motors that would be 22.04 pounds. This test actually confirmed that the motor and propeller would produce enough thrust for the aircraft design. Additionally, the photo in the slide demonstrates all of the control surfaces that were in our aircraft. The rudder flap, elevator, and aileron were simple to manufacture and meet stability criteria while minimizing the size of the aircraft. More specifically, the ailerons were about 20 to 24% of the wing area. The rudder is 25% of the vertical tail area, and the elevator is around 25% of the horizontal tail area.
All right, so to try and maximize the mission scores, sensitivity analysis was conducted, as seen the two figures on the left. These figures illustrate how increasing a certain factor will increase the mission score. Most factors were directly proportional to the score, with the exception of time, which was inversely proportional. These are based on initial conservative estimates, since the weight and space are limited by the other aspects of the aircraft. If successful, this analysis will allow for the team to determine what factor is best to add to have the biggest impact on our score. On the right, we see our power-based constraint analysis, and this was done to ensure that the design is feasible and what will be the most constraining factor. The figure illustrates that the turning will be the most limiting factor, but it should not be an issue with our estimated cruise speed, since we should have a good amount of wing loading to work with.
And upon arrival at our first flight test, we were not able to successfully fly the plane. The center of gravity was too far back, which ended up causing our plane to flip. And in order to successfully achieve a stable flight, the center of gravity will need to be moved farther forward, and the fuselage will also need to be lengthened to allow for better control. Unfortunately, due to time constraints, we were unable to make these changes and have a working plane by the competition deadline.